Okay, here to talk about some behaviors of functions that are noted on their graphs. If you are in my class, we are on page 27 in the Seafoam Green packet. Right, so when looking at the behavior of a function on a graph, it's helpful to identify key features, and we're going to recognize if the function is positive or negative, if it's increasing or decreasing, and find the domain in which it's increasing, decreasing, and its end behavior, as well as some of the extrema, which are known as the relative max and relative min. So when we look at the graph of functions, I like to think about them as if I am on a roller coaster, where I am going down at first, which would make it decreasing, and then I switch to going up, which would make the function increasing from here to here. Switches again, it's now decreasing all the way until we hit that change point at the bottom where it starts to go back up. It would be increasing, and then at this point it starts to go back down and it's decreasing again. Okay, so there you have your increasing, decreasing, increasing, decreasing. Talking about whether or not a function is positive or negative is very simple. If the piece of the function lies below the x-axis, that's where it would be negative. If it is above the x-axis, where it is here, it's positive. And then again, it's below over here, so it would be negative from these points. And when it goes above, it's positive again. Okay, the end behavior talks about what it's doing at the end. So although this arrow may look like it's pointing up, if we were to go from left to right, our function would be decreasing. And the same thing on this side, the end behavior here, it is decreasing. This graph is showing a bunch of increasing, decreasing. It looks a little bit confusing. So I'll just show if we were on a roller coaster, in this part right here, I would be decreasing until about this point at -3. And then I would start to be going up as I'm going left to right. So this would be increasing. And that goes until about -1 on the x-axis. And then it starts to go down again until about 2, increasing again until over to 4, and then decreasing. So we have increasing, decreasing. Anywhere that your function is above the x-axis, so from here to here and over here, it's positive. And anywhere that it's below would be negative. Okay, I'm going to flip the page. On this one, we have a graph where we are able to see our relative maxima and relative minima. And that is any time that your graph is going to dip low or jump really high, those would be your relative minimas max. And they are categorized or labeled by the point at which they drop, the lowest point here, or the top, the highest point there. So you'll see here, this one dips down. The lowest point of it here is at this point -3, -2, so that's going to be considered a relative minima. And then it goes up, and right at that top, if we were on a roller coaster, that's the top where you get really scared right before it starts to go down. That's going to be one of the maximas, and that happens at point -1, 2, so that's where we get that point there. And so on for this one, and then jumps up again for this one. Okay, so in this particular function graph, we have 2 maxima and 2 minima. But I want to talk about how we find the increasing, decreasing domains. So if we were going to talk about this function in particular, I don't know what's happening on this side. I just know that it's going up over here. So if I were to start from here, I'm going to call this negative infinity, because I don't actually know where it is. And I'm going to say that it's decreasing from negative infinity until this turning point here, -3. Okay, if I was doing interval notation like that, but when we're doing increasing, decreasing domains, we're going to write them as inequalities. So we'll have negative infinity less than x, because that's always the domain x, to -3. This is where my function is decreasing. My function is also decreasing here. This one's going down from here to here. So that's going to be -1, 2, 2. So to write that, it would be from -1 to 2. And it's decreasing again one more time over here, which is at 4 on the x-axis, to I don't know where. So I'm going to say 4 to positive infinity. Those are all the places that this graph is decreasing. It's increasing from this spot to this spot, which is -3 to -1. So I say -3 less than x -1, which really just means between -3 and -1. And then it's also increasing in this spot here, which is from 2 to 4. So it's increasing also between 2 and 4. And that's how we're going to write where it's increasing or decreasing. Then we have a graph like this, where we have no slope here. It's not increasing or decreasing. This is called constant. This is where your function would be constant. Not increasing or decreasing, but constant. Then we have decreasing, increasing. This entire graph is a function is positive because it never dips below the x-axis. And as far as a relative maxima, there is not one that we can see, but there's a relative min, and that's going to be at 3, 0. Okay, so let's try one of these questions, or all three. See if we can get them done within the next few minutes. This function is graphed below. Over which interval is f of x increasing? So we have it increasing from here to here. And what x values are those? 0 to 2. So first I know that it's increasing from 0 to 2. And it's also increasing here from C to D, which is 4 to 8. Okay, and over which intervals is it decreasing? Well, I only have it going down from B to C, which is 2 to 4. So decreasing x between 2 to 4. And it's not doing anything here. It's just constant. So that's where we're going to answer part C. From D to E, it's constant. Those x values are 8 to 10. So between 8 and 10. Okay, number 2. For this graph, which point is a relative minimum? That's any spot that it goes really low, which would be right here. And what point is that? It's 1, 2, 3, -3. Whoops, I did that wrong. Swappy. They asked for maximum. I just did the minimum. So now I'll put the maximum in the other spot. The maximum is 1 to -3, up 1, 2, 3, 4, 5. -3, 5. And don't forget to switch those. And then we have this last question. For the graph of this function, state all the intervals where the function is positive or negative. Okay, so again, they want intervals, so we're going to write that like we would here. It's positive from I don't know where to this point here, which is -2. So it is positive from -infinity to 2. And then it's negative on all this spot because it's under here. I like to think of this as the ground, and anything underneath it is negative. So then we're going to be positive again from here to here, which is 0 to 2.5. State all intervals where it is increasing, decreasing, or constant. I'm going to leave that for you to do because we just did it up here. So follow the lead up here, rewind the video and rewatch if you need to. And then state any relative maxima or minima. I think that you can handle that one on your own too. Right, and we will go over it and discuss it later on. Cheerio.